In a simple electrical circuit, the total voltage drop V volts is given by the differential equation Ri plus L di over dt is equal to V, where I is the current in amps at time t, R is the resistance in ohm, and L is the induction in henries. Here is the basic circuit. Given that when t is equal to 0, I is equal to 0, solve the equation to show that I is going to be equal to V over R times 1 minus e to the minus RT over L, and then part B, find the limiting value of I. So what happens to I when this goes to infinity, when t goes to infinity. So if we write down our differential equation, Ri plus L di over dt is equal to V. Separating the variables, we get L di dt is equal to V minus RT. So what we've done is we've taken Ri over to this side. And then what we need to do, because we're going to have to integrate this side with respect to I, we're going to take all of this over here and then all of this over here. So it will become 1 over V minus Ri di dt is equal to 1 over L. So writing that out, now what we do is we integrate both sides with respect to t. And doing that, the left-hand side becomes 1 over V minus Ri di dt dt. The right-hand side becomes the integral 1 over L dt. Obviously, the dt's cancel out, so we now have to integrate this with respect to I. Hence, we needed the I variable to be on the left-hand side. Is equal to the integral 1 over L dt. Now, this comes from the idea that of ln of V minus Ri. If we were to differentiate that, then this is type f dashed over f dash of x over f of x. This will become minus r, so the r and v are constant, over the denominator. So we've got a minus r times too much, so we'll need to compensate this by putting a minus 1 over r here. And this will be equal to t over L plus c. Now, good time now to try and find out what c is. When t is equal to 0, I is 0. So this bit will be 0, and this here will be 0. So we're just going to have minus 1 over r ln of v. So c is minus 1 over r ln of v. Substituting that in here instead of c, we get minus 1 over r ln of V minus Ri is equal to t over L, minus the constant of minus 1 over r ln of V. Right, if we notice here and here we have the same thing, so what would be a good idea to take this over to this side? So we get 1 over r, makes it positive as well, ln of V minus 1 over r ln of V minus Ri is equal to t over L, a common factor of 1 over r. So we've got 1 over r ln of V minus ln of V minus Ri is equal to t over L. If we now move this up here, we get ln of V minus ln of V minus Ri is equal to RT over L. What we need to do is make this a single logarithm. So we do that by doing log to the base a of x minus log to the base n a of y is equal to log to the base a of x over y. So we're going to have ln of v over v minus Ri is equal to rt minus L. And then using the basic idea of logarithm, which is log to the base a of b is equal to c, implies that b is e to the c. So if this is b, then, and the base is e, so we're going to have v over v minus Ri is equal e to the RT over L. Okay, so what we need to do now is try to make I here the subject. Now the way to do this is to take the denominator and multiply it onto this side. So we get v is equal to e to the RT over L times v minus Ri. We're going to have v is equal to v to the e to the RT over L minus Ri e to the RT over L as we want I to be positive, we'll take this over here and take this V over to this side. So we get Ri e to the RT over L is equal to V e to the RT over L minus V. Divide both sides by R e to the RT, which will mean on this side we just get I. Here we're going to have V over R, and the e's to the RT over L will cancel out. So we'll get V over R minus here the R e to the RT will cancel. Sorry, here we'll just get, beg your pardon, R here we'll just get V over R e to the RT. Right. We could take out a common factor of V over R, and we're going to be left with 1 minus, now 1 over R e RT over to the L will become e to the minus RT over L as required. Now, if we want to find the limiting value of this, let's rewrite this as 1 over e to the RT, and then as t goes to infinity, because that's what we mean by the limiting value, 1 over RT to the L, or e to the t, will become very, very, very large. So 1 over it will become very, very small. So 1 over RT to the L will go to 0. Therefore, I will go towards V over R, which is interesting. Okay, we can look at this on this GeoGebra app, which I'll put in the notes on the video. So here we have the differential equation and its solutions. And we can see very easily here, as t gets to infinity, then I will be equal to V over R. For example, 4 divided by 1.4 is about 2.85, so we can actually see that from this, okay? And if we change these, we will see that doesn't matter what we change it to be, as t goes to infinity, I will go to being near to V over R, and even if we change L as well. Okay, so this GeoGebra app I'll put in the notes of the video. So this has been a video to show you how to solve a practical example of a differential equation of electrical circuit. I hope you've understood, and I thank you very much for watching.